Hi everyone. First, we would like to thank you for your interest in Automation Studio, the all-in-one, user-friendly circuit creation, simulation, and troubleshooting software for hydraulic, pneumatic, electrical, and PLC. In today's webinar, we will go over the PLC module of Automation Studio, mainly the Allen Bradley, but please note that we also cover Siemens, the IEC, and also the LSIS PLC. We will go over basic manipulation. We'll actually create a PLC circuit that will control a pneumatic and hydraulic circuit. We will put a timer also in that circuit. We'll change properties on some of the components. We'll also show you how to display the addresses instead of displaying tag names in Automation Studio. We'll show you how to also display the addresses on the input card. We'll also show you how to create a custom library in which you can store these components when they've been changed, and also in a library where you can actually put the symbols that you want your students to use to create a specific exercise. We'll also show you how you can control the virtual system using the PLC module. We'll show you how you can also record the screen and share those MP4 video format to your students by YouTube or just by email. And we'll also show you what's coming soon in the PLC at the end of the presentation. So now we've seen before how to build those. So obviously Automation Studio offers the great capability of having multiple technology into one project to simulate. So here we have hydraulics and pneumatic. So what I'm going to do, I'm going to build a basic electrical circuit, because sometimes when we teach PLC, we start with these basic relay logic circuit, okay? So I'm going to do a very quick one for some who weren't here the past few days, and then I'm going to open a demo, which this will be automatically done for us. So let's say I want to, my sequence that I want, it's actually A plus, B plus, wait 3 seconds, and then B minus and A minus. This is my sequence. So I'm going to come here in the electrical control, and this is where I can find the little relay logic circuits, okay? So I can actually drag and drop my components like that. I'm going to take like a push button here. So when I hit start, so let's name this start, I want to energize a relay. So I'm going to drag here a relay that will name, let's say CR1. You can put any names you want, it doesn't matter, okay? Then I'm going to connect these together. Then I want that when I push start, I want to actually latch my start button. So I'm going to drag and drop below it, a normally open contact, and as soon as I drop it, the software asks me to which relay do I belong. Let's filter for C. You see CR1 is here. I double click on it. And now if I attach like this, now it's going to be latch. Okay. So when I push start, I want my cylinder A to extend. So I'm going to copy this contact, because I could drag another one and re-tag it. But if I copy it, it keeps all its properties. So I can either go copy and paste. I can do Control-C, Control-V to paste it, or I can simply hit the Control key and just drag it down like that, and it makes another copy of it. So when CR1 is activated, I want to trigger A plus on this valve. So I'm going to drag here now a solenoid on my electrical diagram, and I will call this, let's say, A plus. Then I'm going to connect that together. You see it's a bit off, but components stay connected, so I can actually move this wherever I want to realign the circuit. So then A is going to come out, and I need to latch this because you see it's a spring return. So if I cut the signal, it's just going to go back right away. So I need to latch it so it goes to the end, and that's why I latched my button here. And then when I reach A1, I want B to extend. So I'm going to take a normally open proximity switch like that. I drop it on my schematic, and there's a question mark because it needs to be connected to A1, for example. So I'm going to click twice on it, filter for A, and here's A1. Click twice, and now I'm going to connect this here also, and that is going to trigger my B+. So I'm going to take another solenoid like that, and I'm going to name this, let's say, B+. Again, I'm a bit off, but again, it's easy just to take it and lift like that to bring it up. So you see, this is how easy it is, okay, to create your electrical diagram. And if I start the simulation, nothing happened basically because I forgot to assign my coils on my valve. So I'm going to stop the simulation. I'm going to click on this directional valve, choose a solenoid on the valve, and I'm going to filter for, this is going to be A+. So if my filter A is already there, A+ is here, click twice. You see the question mark here change to A+, and at the bottom here you see a line that confirms that the link is made also. Then when I close, now you see I have an A+ on that valve. Then I'm going to need to assign the left one here to B+. So click twice on it, select the left one, filter for B, and here's B+. Click twice, and now it is connected. So if I launch the simulation again, push here, A extend, then B extend. So I can stop and then keep going until I build my ladder diagram that I want, okay? But I'm going to open a demo, a circuit of this one, a bit more complete, okay? Just so we don't waste too much time doing the electrical control because we've done it a couple of times this week with the electro-pneumatic and the electro-hydraulic. So this is basically here, the circuit that I wanted to build all the way through, okay? So I've put the A, I need to, then I put a timer here, okay? So it's an on delay coil. If I click on it twice, this is something important. You see, if I go into the data here, I can't seem to be able to change the time. And that's important. You see, there's some yellow stars here. And once this is activated, it means that it only shows a couple of fields that were pre-selected. Don't question the pre-selection. I don't know who did it, but sometimes they're a bit weird, okay? So if you uncheck this, you see there's many more things that you can do, and this is where you can actually set the time delay. So I'm going to put here 3 seconds instead. And I can display this on my circuit if I want. You see when I check this box, you see here on right beside, it goes away or it shows. This is how you display information on your schematic. So now I have my 3-second timer here. And obviously this will, so this is the logic that I want. So if I start the simulation, so A+, B+, count to 3, goes back, and then A goes back. So that's my sequence. Another point I want to show also is that sometimes people have asked us, can we make those lines more visible to be able to follow more easily the color or things like that, okay? Yes, you can. If you stop, let's say, the simulation in edit mode, if I right-click on the page and I go document properties, if I click on electrical here, this is where I can configure all my properties. The colors of the line. You don't like the pink here? Take another color if you want. It's really up to you to decide, okay? And you see here, wire thickness. So in simulation. So if I change this, for example, to 2 millimeters, you see we have a preview here of the thickness of the line now. So if I say, okay, I want 2 millimeters, I'm going to approve. It says I changed the standard. For sure, I just did it. And now look what's going to happen when I'm going to start the simulation. You see how the lines are much thicker now. So this could be an easier way to follow what's happening during the simulation. Okay, so this is the way that you can do to put the line thicker. So let me just go back and put it the normal way. Okay, so I'm going to go back here, electrical standard, and in here I'm going to change it back to 0.1 millimeter. Okay, and then now if I simulate again, it's going to be back to normal size. Okay, so that's what I wanted to show you. So the star is important to take it off if you don't see some parameters that you want. It's like, you know, like for example, if you take like a light and you want to change the color of the light, you will not be able to do it unless you uncheck the star because it's not one of the favorite fields. Okay, so I uncheck the star and I leave it unchecked. This way I always see all the possible properties that I can change. Okay, so that being said, now let's do a PLC circuit. Okay, so I'm just going to take this pneumatic part here and I'm going to bring it down here because I'm going to need a bit more space, and I'm going to do zoom all components. Okay, let me just move that a bit to the left. Let's say here. And now I'm going to actually I'm not going to reinvent the wheel and redo all the links. So I'm going to take the component from here that I'm going to need on my PLC. So I'm going to need my 24 volt, let's say. You see also something. You see when I drag let me do that again. Let's say if I just drag it, you see that the wire follows all the time? So if you want to disconnect, you hold the shift key down and you move it like that. Okay? So I'm going to take the 0 volt. I'm going to also take all my inputs. So my sensors. So this one, A1, B1, A0, and B0. So I'm going to drag those here. Let me just move them a bit like one beside the other, like this. And I'm also going to take all my outputs. Oh, I forgot to take my start. My start is an input also, okay? Yep, you see, I moved it without holding the shift. So hold the shift and move it. And I'm going to take all my outputs, so A plus, B plus, and B minus. And I'm going to move them here. I'm going to erase all that because now I'm going to need to work with the Allen Bradley library here, in which I have my contacts and everything that goes with Allen Bradley. So I'm going to take out the rungs. This is where I'm going to write the program inside. I'm going to expand it a bit. I need more rungs. Then I'm going to take the input and output card. These cards, they're not in the Allen Bradley section. Okay, so you need to go into the electrical control PLC cards. They've put them there because on this card, the only element that you can connect are electrical components, like outside element. That's why they put them there. So if I drag this input here like that, and then I'm going to put the output on the other side. It's really up to you. I mean, you can put like the rungs below and put the cards one beside each other. It's really up to you to decide, okay? You see, for example, here I have presently 8 input. If you want to have more, you can click twice on it. Again, if the star is checked, you don't know that you can expand this. So if you uncheck the star, you see here now you have input number. I can go to 16, let's say. And now I'm going to get 16 input. Okay? So let's wire up my outside components first. So I'm going to put the 24 volt here. I'm going to put my start to my in 0, like this. I'm going to put my sensor 1 to, let's say I'm going to put more space between them. So like that on input 4, input 6, and input 8. I'm going to put my common at the bottom. And I'm going to connect these together now. You see, by the way, for some who maybe did not see the other presentation, if you click twice, you see I don't have a target sign to connect here, you know? But if I want to connect, I double click and I will insert automatically a connection port, okay? Okay, by the way, yes, I just had a quick question. Yes, we can use also Siemens components, okay? We have Allen Bradley, but we also have Siemens here, okay? So basically when we use the contacts, it looks pretty much the same, but if you start using timers and counters, it will look different, and I will show that to you later on, okay? So now I'm going to do the same thing with my output this time. So let's select those, move them here on my output side. Okay, so you see I'm a bit on the side of my screen here, right? So what I'm going to do, you see I have more space to the left, so let's do a Control A for select all and just move it like this. By the way, okay, when you're going to take out your rungs like that, you'll see that it's going to take almost all your page, your 8.5 by 11 page that comes open the first time, okay? So what I did before that maybe I should have showed you is I right-clicked on the document here, I went in document properties, and I simply changed my scale here to 50%, okay? That means that I can put a lot more components on the same size because everything is scaled back halfway, okay? So keep in mind, anything the drawing scale is where you can get more space but remain on an 8.5 by 11 sheet. Or else you come here and you choose a different type of sheet, 11 by 17 or whatever you want also, okay? Sorry about that, but I thought it was important for you to know. So I'm going to go now. You have more space. So I'm going to need to have a 24 volt and 0 volt there too. So I'm going to hold the control key, drag the 24, the control key, drag the 0. By the way, Automation Studio does not make any difference if you put the 24 on top or at the bottom, okay? So it's for you to decide. So on the 0, I'm going to put the A plus, B plus here, and B minus over here. So now I'm basically just connecting my element to my cards, okay? And after that, we're going to go right into the PLC to write the program. So now let's do the exact same thing that we did before with the electrical control. So I'm going to go in the PLC here, so Allen Bradley, and I'm going to take a normally open contact. As I drop it like this, there's a question mark because it needs to be linked to an input. So I need to link that to my start. So in 0. So click twice here, go to variable assignment, filter for in, I, and you see my in 0 is here. Click twice, and now it is linked to my in 0. Then I'm going to energize an internal relay, let's say internal bit. So when I drop this here, I can give it a name. So let's say I'm giving it B3 column 0/1. Here you can put whatever you want, by the way, okay? Maybe this is wrong, so don't judge me here. It's just that I think it looks like that, so I'm going to just do OK. And this is my internal bit, like this. Because you remember I have to latch this to keep my valve here, which is a spring return, to keep it activated, okay? So now I'm going to put a normally open contact below it because I need to latch that. And I'm going to click twice on it to link it to B3. Click twice, filter for B, and here's my B3. And I'm going to put that here to latch it. So now, if I just simulate that quickly, if I start, you see when I push start here, it is latch. So your students can actually test their program as they go and make sure it goes the way it should, okay? So then what I need to do is that I need to actually activate my cylinder A plus when this is going to be activated. So I'm going to copy this B3, hold on to the control key, copy it down here, connect this here, and I'm going to need to energize the output for A plus, output 0. So I'm going to take this here. I'm going to write, let's say, out 0. And now I need to link it to the card. So I'm going to click twice on it, filter for out, so O, and here's my out 0. You see when I click twice, you see at the bottom here, the line showed up to show that it is connected. And now if I go if I connect this again, that should activate my out 0. Let's try it. If I simulate, push once, and there you go, my out 0 is activated. So it's basically like doing like electrical control, but you're just working it through the ladder diagram. So after that, when this is going out, now what I'm going to do, I'm going to read my A1. So the A1 is input 2. So no problem, I'm going to take here and link that to input 2. Click twice on it, filter for I, in 2. And then I'm going to connect this here. And when it's going to reach A1, I want B plus to go out. So again, I'm going to put an output here. And my B plus is on out 2. So let's put out 2 here. I'm going to connect this like that. And if I click twice on it, you see at the bottom there's no association made. So I'm going to filter now for out, and it's out 2. Click twice, and now it's made. Okay, so then you see it's not aligned. I can just select and move it a bit to the left like that. So this is going to be my cylinder B exiting. Then when B is going to reach B1, I want to start a timer. So, okay, so let's put one here. So B1 is on input 4. Click twice, filter for I, input 4. And now I'm going to put a timer, so I'm going to go in the timer section, a non-delay timer, and I'm going to connect this like that. So that will start my timer. And when my timer finish count, I want to activate another rung here. So I'm going to put a contact here, and that I want to link it to the done bit of this timer. So I'm going to click twice on it, filter for DN for the done bit, and here it is. And you see when you go over it, it shows you like a tooltip. This is a T4 column L21, like it's written here on the drawing. Click twice, and now it's done. You see now it just displayed DN. If you want to show more detail, if you click twice on it here, and you go to the data tab, you see you can also check that you want to display the address. And that will display it here. You can place it wherever you want. Once it's placed, it will remain at that location. Okay? So that could be a way to display more information here. So this is going to go, and when the timer is finished, I want to activate B minus. Okay? So I'm going to just go here. B minus is output 4. So out 4. And I'm going to click twice to link this to out 4. Like this. But at the same time, I want to also energize another internal bit that I need to work in the circuit. Okay, so let's create another one here. And let's call this B3 column 0/2, for example. By the way, I'm not sure if you can do that in PLC, but you know, I'm just going to energize 2 like that on the output. I think you could, but I'm not too sure, okay? I'm going to take a normally open here again, and I'm going to link that to my internal bit B3 because I want to latch this, okay? Because I want my out 4 here to keep energized. So click twice, filter for B, and here's my second bit here. So I can connect this like this. Okay. Now, when this is going to be going B minus, what I want to do is I want actually to cut the signal of my initial latch up there. So when I'm going to reach A0, when I'm going to reach B0, when it retracts, sorry about that. So B0 is on input 8. So here, I'm going to link that to input 8. So I'm doing it like a student would do, you know, just walking through it starting the simulation once in a while, testing things as he goes, and make sure the circuit works. So this is input 8. So when it retracts, then I want to cut the signal here to make A retract. So I'm going to put here another internal bit called B3 column 0/3, for example, like this. And I'm going to put a normally closed contact up here of my B3 because I'm going to cut this so A can return. Click twice, filter for B, and here's B3. Okay? So, but at one point, this is going to be activated. It will disconnect here. But let's try what's happening now. If I click here, it doesn't work because you see my B output here is already energized because my B0 is also already energized. So, okay, so what I need to do is I need to make sure that this is not good until at least my sequence is started. So I'm going to take here a normally open contact to cut this wrong. And let's connect it with the internal bit number here. Okay, so just the wrong before it. So B2. Okay, now let's try this. A extend, B extend, timer start to count. Oh, I left it to 10 seconds. Okay, so sorry about that, but we're just going to wait a bit. Energize that, but B is not returning because B plus is still activated. So I also need to cut this. Okay, so then I'm going to use here a normally close on my output 2 of the bit 2 that's here also. Let's try that. So he says, so you can work your way like that and, you know, make it so everything works fine. So let's start again. Start. A plus, B plus. Oh, let me just, give me a second. Okay, I'm just going to click twice on that timer and change the preset time here. Again, if you don't show the star, you see, you don't even see the timer. So that star, just uncheck it and just leave it unchecked, okay? Let's put 3 seconds here instead. So let's start simulation again. Hit start. A plus. Yep, sorry, I didn't reset correctly. So let me just go here, start. Let me just stop that. Sorry, I didn't finish my cycle. So start, A plus, B plus, count to 3. It goes back. It goes back like that. But I can't seem to relaunch it because I'm still latching this. So what I'm going to do, I guess, I'm going to put the A0 to break everything here. So my A0, click twice, filter for A0. A0. Oh, no, sorry. You see, I don't link that. I need to link it to my card, which is input 6. Sorry about that. Now you see I need to click here first to delete the connection. And then I'll be able to link it to something else in 6. So let's try it again. Start. A plus, B plus, count to 3. B minus, A minus. Is everything reset correctly? A plus, yes it is. So I've done my assignment. By the way, I could have done it correctly the first time, but I wanted to go through all the scenarios with you so you see, that how students would do it. And this is and the same thing as we did before. This is something that you just drag and drop from the library, you create, and that's it, okay? Using this method like that, you can also, we have, okay, in version 7 that's coming out, I want to show you something here. We have some updates on the PLC side. By the way, this PLC that we have here, it's been a PLC it's been going on for a little while. Okay, so there's some issues with it. Okay, like the latch and unlatch. they need to be connected together like that because we cannot write on the same variable in this version, okay? Like if you use a counter up and counter down, you're going to have to use a sum to do the calculation of going up and going down, okay? So we know that these are little problems, okay, that is, it's not consequent with the programming software. So we have make an update in version 7. We have redid completely the Allen Bradley library, and now it's called the 500 and the 5000. We support both, okay? So this will be, and I'm just going to show you quickly also what's new with this version, okay? The version 7 will be available, like I said, this fall. There was supposed to be beginning of the fall, but in software development, you know, sometimes they develop something, they have little bugs here and there, so they have to go back and do it. So I anticipate late this fall or early next year, okay? So something new that we're going to have in version 7, but it's not going to be in the software itself. You just need to send us a request and we'll send them to you, is we've actually created images of PLC. Let me show that to you. Let me open the library here. Okay, because a lot of the time, all the PLC trainers out there, most of them, they come and the PLC is already connected. So students don't really practice the wire up of the PLC and things like that, okay? So what we can do here, for example, I'm going to keep all this, but again, I'm going to disconnect this, keep my 20-volt, my 0. I'm going to take all this, keep it. And my output, I'm going to do the same thing. I'm going to keep my output again. And I'm going to delete this input card and this like that. And you'll see why I'm doing this, okay? I'm going to take these rung and just move it sideways. Okay, this is my program. And now in the library here, AB, I have some PLCs like that, like Compact Logic, MicroLogic 1000. So we have a couple of them that you can actually drag and use with, hold on, this is not the good library I just opened, sorry. It's PLC, I need to come here. Sorry about that. This is the one, because this one has more model, that's why. It's development, you know. So we have here, we also have the MicroLogic 1100, MicroLogic 1000, and the Compact Logic. So let's drag the Compact Logic to see. So you see what we've done here is that we've put like a picture of the PLC. And because it's hard for us to go connect there because there's too many wires, you know, it would not show in here. We did like a terminal block at the bottom like that where you can actually do the connections. Okay? So I'm just going to take my inputs, move them down here. I'm going to wire up the PLC. So I'm going to put the 24 volt here like that. I can move this down. My 0 volt. And now I'm going to energize my inputs. So I'm going to put my start on my input 0, this one on input 1, on input 2, 3, and 4. And I'm going to have to energize those. So let me bring my 24 volt down here. Okay? Now I'm going to put my outputs. So bring these outputs like that here. And there's a common element, there's a comment at the bottom here that matches the set. So the first category, the comment is this one here. So I can connect like that. This is going to be the 0, output 1, output 2. Okay, so now I've, instead of having my input-output card that in Automation Studio, I actually connected them on this looking PLC like that. Okay, but now I've lost my inputs link and some of the output links I have to redo, because if I click twice on the PLC, I'm going to see how this PLC was addressed. And the way it was addressed, it's Boolean input 0 to 15 and Boolean output 0 to 15. So it works a bit differently. So now I just have to remake those links. So here, it's my Boolean input 0. So if I click twice on it, I'm going to filter for B. So Boolean input 0. Click twice, and now the link is made, BIO. Okay? Now my output here, this was output 0, and it's still output 0, but we just seen that it's BO0 now. So click twice on it. And just so you know, I'm going to put here BO0. I could have done that straight from the library. Okay, instead of using my card first and then moving on to this, I could have dragged this out directly first and do my assignment right away to this one. But I wanted to show you both ways in the software. So this is actually linked to my input 1 for A1. So click twice. Let me do all my input first. Okay, so BI, and this is 1. Now this one here, this with the timer, it was linked to my B1, which is input 2. Click twice, BI2. Then this one here that we had, this was the A0 when it came back. So my A0 is going to be to input 3. So click twice here, BI3. And this one was when my B0 was retracted. So this is going to be B0, my input 4. Click twice, BI4. So now let's do the output. So this one we did, B0. This one was out2. Out2 was actually my B+, which now is my out1. Click twice on it. Change that for BO1 and link it to BO1. Now I'm going to go here. This output 4 was for B-, which was now B- is, let me zoom in so you see, so it's output 2. So click here twice, BO2. So let me just go here. Let me rename that to BO2 so we know what we're talking about. And here, BO2, double click, make the link. So now if I simulate again, let me just start simulation, zoom all. So now if I push start, the circuit works the same as before. But if I zoom in on the PLC, you'll see that we're also energizing the inputs and outputs to show a bit like the real look of what would happen on the PLC, for example. So this is something that we've been doing for the version 7. Okay, so this is coming, like I said before, close. Okay, so this year or beginning of next year. And we have different models. So let me show you what we've done so far. So we have the micrologic that like that. We have this one here. Okay, we work with what we have, okay? So sometimes it may not be exactly like you would want to see it, but you know, it does the job for most of the part. Here we also have, let's say, the 1200 Siemens. Okay. We also have the 200, S7-200. Because these were modeled but asked by some of the customers, so that's why we have them. But it's really made on a request basis, basically. Here we also have some Koyo. So we have the click, and we also have the Direct Logic 6. So they all work the same way. You just wire them up. You know, maybe if you click twice on this Siemens, for example, you'll find out that the addresses is I0.0 instead of the BYI that we had before, okay? So all of them may have a different addresses. So once you click twice on it, you will know by viewing them in the variable assignment. Okay, so this is what also is coming with the PLC. So let me show you something also with the PLC. Again, the regular PLC that we used before. Let me show you a demo here. This one is using the Siemens. You know, we've had a lot of people asking about those because, you know, like, for example, it's not obvious that you need to jump those and things like that. So we feel that it's going to be something very useful for the students. So you see here, if I simulate, I flip that switch, my timer count to 3. Then you see my LEDs opening on my PLC. And depending on the sequence that I wrote, it's going to work. But instead, again, of using the PLC card, we use it this way. Okay, so it could be a bit more visual for the students to use like that. Also with the PLC, we also have virtual systems. These virtual systems are pre-animated machine for which the students can only build the logic to control it, like conveyor, traffic light, intersection, car wash, metal bender, drilling factory, pick and place stamp. So let me open one, for example. Let me open the drilling factory here. I'm opening this one because for this model, I also have the sequential function chart that controls that. And we also support structured text. Okay, so you see here, if I zoom out, this is only inputs and outputs. There's no pneumatic or hydraulic involved here. So the students have to look at the input and the output and actually make it on the ladder here. So if I simulate, I hit start, and then the logic that's here is controlling the machine on the left. Like if I was the teacher, I would say something different, that A needs to remain out until C is fully retracted. Because now A is moving while C is still on the disk, which could make it move. So you can stop there. You can erase all that if you want. Provide the file like this to the students, and it's for them to work on the logic in the PLC. Okay? It's really up to you. So you can open the system and work like that. Let me open another one, the same machine, but this time controlled with the sequential function chart. Okay? So steps, transitions, step transitions. I know that Allen Bradley is coming a bit more towards this way. We've been using this for a long time in Quebec and in Europe. It's a different way of programming PLC. I think it's much easier, but I mean, again, when you know this, you know it's, but let me zoom out a bit here. So here we have the same machine that we had in the previous demo. Let me just move it like that. If I start simulation, you'll see on this one, A remain out until C is retracted. So in our SFC, we see every true variable, but we don't care if it's true here because we're at the step 1. So if I hit start, A extend. When it's out, extend. C retract. When your C is in, A retract, and go like that. So if you want, you can go simulation, slow motion. So when A is it's extending now. When A will be fully out, I'm going to start the drill on and extend C. When C is going to be fully extended, I'm going to retract C. I could have put a timer there so it stays in the block for 2-3 seconds, and then when C is in, I'm going to retract A. So it's really a sequential way of programming PLC, which, and then we have ORs and things like that. So it could be complex at one point. It's for you to decide, you know, how you want to do it. Okay, so we have virtual systems like that in which you can control them by electrical control, by PLC, or by SFC if you want, or structured text, is up to you. I forgot to show you something important, so I'm going to reopen my demo that I had before on here with the PLC. The one that was finished, I think it's this one here. No, I did not this. Okay, hold on. That's not the one that I want. Sorry about that. I want the second one, PLC 2. Okay. Okay, not really the one that I wanted, but let me just do something here. I'm going to erase that. I'm going to take back an input card, PLC input, and I'm going to link this one to input 0. Okay, for what I need to show you, I just need to assign one variable like that. Okay. You see here, we show an internal ID for Automation Studio, which is E1-1 input 0. If you prefer to show something different, that looks more like an address, okay? You can click twice on your card here, and you go into the data, and you can decide to display the address. If you click here, oh, this one here, sorry, okay? If I change this here, and I name it, let's say, more like Allen Bradley. Let's say it's going to be I column 0 slash, okay? Then if I close, you see I have now all the addresses beside like that. And now my contact shows an internal ID, but I wanted to show the address instead. I can click twice on this contact and decide to display the address here. So when I close, the address is over here. I want to get rid of the tag here. So I select it, I do delete, and I place it here, the input like this. So if you prefer to show something like that, okay, you remember in the past presentation, I showed you that you can create custom library. So if you create a custom library, let's create one now, for some that weren't here the previous presentation. Let's go on my desktop here in training, and let's just save that, and let's call it, let's say, PLC library, okay? I could have named it the school name or whatever I want, PLC, sorry. So you see now I have a library called PLC. I can create a category, and let's call card, IO card, let's say, IO card. And I can, oh my God, okay, sorry. I've hit many buttons here. IO card. Okay, that's better. I can drag this card while displaying these in the library like that. So next time the students takes it out, it's going to automatically display it like that. And when I click twice on that contact and I link it, let's say, to in 5 and 2, for example, in 2, you see it shows the address now. So I want my students to always see the address by default. I drag this contact in the library, displaying the address. So next time I take it out here and I link it to input 4, right away it's going to show the address. I can do the same thing on the output card also. You want to save in your library an input card with 16 input, you come here, you put 16 input, then you save it here as being a card of 16 input, which you can rename here if you want, 16 input card. Okay, so this is how you can display the address, and you can do the same thing on the output also. The output card is here. I click twice on it. Let's say I want the address here to be displayed. I can put whatever I want. I can put Toto 0 slash if I want, you know. And you see on my card, oh, sorry, I didn't check the right one. I need to check this one here. And then you see Toto 0, 0, 1, 1, 2, 3, 4, 5. And you see my output, if I reassign them, if I click here twice, and I say that I want to link it to I want to show the address instead. You see what it's going to show now? Total 000. So if all your program is done and you say, oh, I should have changed my addresses, if you click twice on it and you change total for, let's say, Chris, again, for any reason, you see all here it changed to Chris. And if I click twice on my contact, it's going to be, it should be refreshed to, oh no, I need to reassign it to Chris. Sorry about that. Okay. So this is just something like that that you can play with your card and put in your library so students can show more how you wanted to see it. Now I'm going to show you a little video of what's coming in version 7. This module was completely redone. Okay. We've kept, by the way, the old way. So if you want to keep doing it this way, fine, you can do it. But just to show you, so you see, in version 7, we have to do a new diagram of the PLC, choose the 5000 or the 500. I can take a counter like this, and now we can write in the same variable. And you see, the interface is different also to assign the name. This is the 5000, so I can put like a tag name. So I'm just going to name it, let's say, counter 1. Preset values accumulated. I don't have to put that. So they say that this was redone more to look more like the PLC programming software. Okay. If you use a 500, you work by addresses. And something pretty cool also is that when you put, let's say, like a contact, well, I should have put a normally open. I think I'm going to change it to a normally open. Hold on. Where's the video? Streaming now. Yeah, the open contact. Okay, so I name it test. I did another one? Okay, sorry. I put on, and then I put another counter, which I simply click here twice to make the link together. So I click here. Then the counter is going to be linked to the same one. So if I close this window, you see now in this version, we can write very easily in the same variable. So we don't need to use a sum anymore. It's really, really been updated. It's really different. And you'll see it's going to be a lot more, offering a lot more possibilities. We have sequencers now. We have a lot of things that we didn't have in the one that we have right now. And if you go in simulation, you'll see I can click twice on the contact to manually overwrite it. So I'm counting up and counting down. So for some of you that have been using our PLC now, this is something cool because now at least it's working like it should. We can put like a reset here too. And then we can name it to reset as well. This is going to work also with the PLC that we did, with the images, because this is just the programmation part that has been redone, okay? And also there's ways of, when you put like an input, you can monitor the value in hexadecimal, all kinds of, it really changed. And we're going to create videos on this module, obviously when they come out, because there's a lot more possibilities than before, okay? So I know some of you have been waiting for something like that, so this is coming soon. And also something I wanted to show is that you see if you go into the components, so we have the bits like that, timers, compare. So we have feature here that we maybe that I've had in the past one. Okay, so we always try to improve and add more, and like this. Also, our PLC, our software is OPC client. So if you have an OPC server, like RSLink is an OPC server, okay? So if I just close this and open this here to show you, this is an example where I'm having a machine like that, which I control manually by just triggering push buttons. As simple as that, okay? But down the road, I'm going to switch this here to the PLC mode, and you see when I trigger the PLC, it's controlling the circuit on the screen. So we have the capability of exchanging variable with the PLC through OPC. Okay, we oftenly use here Kepware as an OPC server. It's a free server that it supports many brands of PLC. and it runs for 2 hours, and then you can just stop it and restart it and do it again, okay? But you can actually communicate. So any tools that has an OPC server, you may use Arduino units. Some of them have an OPC server in them, okay? So this is something I wanted to share with you about what could be done with the OPC connectivity and the PLC. So this is pretty much what I wanted to show you. And obviously, to wrap up the week, we can do with Automation Studio a demo like this, where we integrate a bunch of different technologies together to create an entire mechatronic system, for example. And just to show that we can also link like buttons, toggle switch, lights. You know, I didn't show that to you, but you see, for example, if I want to put a toggle switch like that, all I do is I choose an auxiliary contact like that, push button, and I link it to this toggle switch, okay? So if I zoom all, start simulation, flip that switch, and then everything works together. Pneumatic, hydraulic, electrical, PLC, and the control panel. Thank you very much again to everyone for being here today. If you have any other questions or comments, please don't hesitate to send us an email. You can visit our website at www.famictech.com/edu to access the educational portion of our website. So thanks again, and have a great day.